I think let's get started. Yep. Cool. Okay. Yeah. So let's get started. So if there are any questions or queries from yesterday's session, we can take up that first and then we'll proceed. Are there any questions or queries from yesterday's session? I think Renath, the quiz and the assignment might have been shared with the students, right?
Today we will share with them, like we will
Okay.
share the drive link with them, and which form we will post in the group itself.
Okay, perfect. Okay, so as you know, we'll be sharing the assignment and the quiz also by today end of the session. So please take that up, and if there are any questions or queries from yesterday's session, we can take that up. So should I take it as a no? There is no query? Okay, if there is no query, then okay. So at least can I? All of you might have installed Jupyter Notebook in their system, and it is up and running. Can I hear a yes from all of you?
Yes, ma'am.
So you are able to run all the commands which we I showed you yesterday, right? Okay.
Yes, ma'am.
So yeah, my apologies. I forgot to share the notebook, but I'll be sharing both the notebooks. Yesterday's one and today one, which we will cover. We'll be sharing the both the notebooks with you guys. By today, you will get all the materials. Okay. Cool. With that, let's get started. So let me share my screen. Yeah. I hope my screen is visible.
Yes, ma'am.
Okay, perfect.
Yes.
So yeah, so just a quick recap. So yesterday we were learning that how do we do EDA, right? So what are the different steps should be performed when you want to do exploratory data analysis? So basically, it includes data cleaning, data validity check, data quality check. So I just give you certain examples or certain broader level criteria how you should be assessing your data, right? So for instance, you should look for your data validity checks, right? Your field should not be empty if it is a mandatory field, right? You have to look for relationship between two columns which is with each other, right? You have to look for an instance blood group type, whatever is business domain, right? As per that domain, these rules or these checks would be different, but you have to keep in mind that that has to be checked, that has to be performed before you even start working on the data, right? And then we also see that data should be consistent. You should look out that if there is a column which might be belonging to different units, so it is all from same unit, right? Be it currency, be it height, be it any other thing, it all has to be in one single unit. Okay. And then we saw that if there are any outliers, we have to remove it from the system. So first, can you tell me what is an outlier? What do you think is an outlier? Anyone? What is an outlier? Yesterday also we discussed. Hmm.
Impossible data that is entered.
Impossible, not really impossible. See, data, it is possibility, right? There is nothing like impossible. But indifferent data, you can say, which is very much different than majority of the data. Okay, that is what we call as an outlier, right? So for an instance, if I tell you I have the employees data, employee salary data, and there is a age column. So what should be the typical range of a age column of a person who is working? If you see
20 to 60.
2 years over there, is it okay? Yes, no. See,
No,
I
ma'am.
thought you guys haven't had your breakfast, or what's the problem? Yeah, somebody was saying something.
2 years is not possible.
2 years. So what is the typical range? Why you are saying 2 years is not possible?
One must
And
first
then
complete
yeah,
their
At least from
education.
18.
from 18, you would see that if somebody is working, at least the valid year age in India is legal age in India is to work is 18 years, right? 18 to, if I say there is some entry with 150 years, again, is it feasible?
No, it is not feasible.
No, it is not, right? See, if I say somebody is working 100 years, again, that is very, very unlikely. That is what I said. That is might be a outlier. Not, at least I have not seen anybody who is of 80 years age, of 90 year age, still works. Right? That is very rare. So that is what we call as outlier. Population or few data points, basically few data points which is very, very different than the entire population. That is what we call as a outliers, which is in distinctively different from other observation. They could be real outlier or mistakes. Both can be the reason. So we can't really use the word impossible because it could be real outliers also. As I said, right? Still there are few people, I you keep on hearing the news that 100-year-olds still they do a lot of work. Okay, so it's not like it is fake or it is unreal. It's just that that's an outlier. That's it. Okay, but the question comes is how do you know? How do you find out outliers? Do you know a few of the techniques?
Matching it with the data.
I'm asking technique. How do you find? Let's say I give you a column, and in each column, and there are 1,000 data points in that. How will you check all 1,000 data points and see whether it is an outlier or no?
No, ma'am.
How will you do it?
Finding the first average ones and then maximum,
We
minimum.
But
check like
average
all
and
the
maximum,
work
how it
flow.
will give you outlier? Average and maximum will not give you outlier, no? Basically what you might be trying to tell is that you have to look for the pattern, or have to look for the distribution, what we call. Okay, so how do we see the distribution? On the left hand side, do you have you seen this chart before?
Yes, ma'am.
What is this chart?
Histogram.
What is the name of this chart?
Histogram.
Histogram. And what does it do? What is on the x-axis, what is on the y-axis? It plots your distribution of the data. So first of all, are there two data points or single data point for this?
Two.
No, it's one. Histogram is only one data point, you are only one column or one feature you are plotting. Just because it has two axes, it doesn't mean that it's two data point, it's two variables. It is only one variable you are plotting. So it's a univariate chart, what we call. Okay, and on x-axis it is the value, and on the y-axis it is the count. So for an instance, if it is a age column, so what you are seeing over here is 0 to 25 year of age people. There are around 27 people who falls between 0 to 25. Similarly, 25 to 50 if you see, so somewhere 25 to 27 you are seeing that that there are close to 35 people. So y-axis it's the frequency count of the people, and on x-axis it's the value. That is how you read this chart. So it shows you a histogram. So what do you see if I ask you what is the majority of the people's age by looking at this chart? What is the majority age of people?
25 to 30.
25 to 30. This is your maximum bar, right? So
Yeah.
typically you can say 25 to 30. This is the maximum, like this is the age which maximum people have. Okay, and if I ask you how many people have roughly more than, let's say, 150? How many people are there more than 150 years of age?
2.
1 to 2.
1 to
So
2,
2.
hardly 1 or 2. This is the bar we are referring to. So that is what histogram shows. It shows your distribution. So by looking at it, can't you tell me if there are any outliers or yes or no?
Yes.
And
Yes,
how
there
do you
is.
know it? We call it as a tail. Look at the tail. So typically what happens when is a perfect distribution. So this is basically a distribution, right? Have you heard this term normal distribution? Have you heard this term normal distribution? Have you seen this kind of a chart?
Yes, ma'am. Line chart.
No, this is not a line chart. Have you seen this kind of shape before?
Binomial distribution chart.
It is called as normal distribution chart or bell-shaped curve. Okay, this is what in ideal scenario people think that my population should look like this. This should be my distribution. Whatever variable it is, age, salary, no matter. Typically, this is like a statistical hypothesis, you can say that. We assume that our data is normally distributed something like this, where my average value and majority of the value, mean, median, mode, all three lies at the center, right? So if some of you don't know what is mean, median, mode, please go and read about it. Okay, so this is what a property of a normal distribution curve, which doesn't have any outliers. But if your distribution here, if I ask you to plot a distribution, it is something like this. Right, let me just give it some other color. Is this distribution is same as this?
No.
No, right? This we call it as it is skewed. It is skewed on the right side, right? It is feeling like somebody has pulled its tail. This portion we call it as a tail. Looks like somebody has pulled its tail towards right side, isn't it? So that is one way to identify if there is any outlier or not. You plot all the histogram of the column. If does not look like this, if it is skewed like this, or it could be left skewed also. It could be like, this entire tail is towards the left. Basically, things are not at center. That is what we call skewed. Okay. So you can say that it has outliers. That is how you identify if your data has outliers or not. Okay, so this is one way to identify. Similarly, there is another chart which is called another technique which is called as a box plot. So this chart you see here, we call it as a box plot. Again, do you know what it is or how do we plot? Anyone?
So basically, the tails are the extreme values, and the box consists of the median, mean, and the mode. The line in the middle of the box is the mean, and the outer ones are the median and the mode. And the points that are outside the extreme values are outliers.
Okay. Partially correct. You rightly said we represent the majority of the data within the box. So it's not mean, median, mode. Basically, it is percentile, right? So this green line you see, this is what median. This is 50th percentile. So let's say if you have the entire data, so I'm not going to tell you what is a percentile. You have to do a little bit of homework about it. But typically, what it either you plot this or this. Okay, both will give you the same perspective. Here you can clearly identify what are outliers. So how this box plot is plotted? First, you will identify what is my 50th percentile. It is nothing but middle value. So let's say I give you 100 values. You will sort them in one ascending order. And then whatever is the middle value, that will be your median or 50th percentile. So it is this value. So similarly, you will look for 25th percentile, which is middle value of first half of it. Correct? So let's say I give you 100 data points, right? So 25th position value will be your 25th percentile. So that is this value. Similarly, this third line of the box is 75th percentile. So you will see the second half middle value, which is again 75th position value. That will be your this line. So this is how you construct a box, and typically we call them this whiskers. So this whiskers is something like maximum allowable values on both side, right? Lower side and the higher side. So it is 1.5 times of this box length. Okay, so for an instance, if here the box length is somewhere around, I think 40, so this maximum length would be somewhere around 60, 1.5 times of 40. Okay, so you can stretch 60 on this side and this side. So if you see here, minimum side, you don't have to stretch 60 because minimum value exists at 0. So this is where it stopped. But on the right side, if you see, or the upper side, if you see, after stretching to 60, it came down to around 120. But you still had two more data points, which was beyond 120, which was somewhere around 140 over here or 135, and here somewhere around 160. So these two data points will be called as outlier. So if so you can just give it a read about it. How do you understand it or interpret box plot? If you understand, well and good. Even if you don't understand completely, just remember that these bubbles, whatever you see, those are nothing but outliers. So wherever you do a box plot for all the columns, let's say if I give you a data set with 10 columns, it is impossible to go one by one and see, right, each record. You quickly plot a box plot for all 10 columns and see if there are bubbles, means that there might be the outlier. If there are no bubbles, you see a complete perfect box plot, then it's fine. You don't have to worry about outliers. Is it clear? Yes, no? Why people were more energetic yesterday than today? Is it because of a lazy Sunday or what it is? Or you're not able to follow? Shall we proceed?
Yes,
Yes,
ma'am.
ma'am.
Okay, cool. One thing I'll ask you. So, what do you think your data, can you plot this with continuous column or discrete column? These two charts.
Continuous, ma'am.
Continuous data. What happens when it is a discrete data? Then what we should do? If it is a discrete data, then what we can do? We can't plot these chart because this is for continuous data only. Histogram or box plot, this both are for for continuous data set. If you have a discrete data set, then you have to plot a bar chart. You can't plot a histogram, you have to plot a bar chart. So same thing, if you plot a bar chart, let's say you have this monthly sales. So monthly sales is your discrete data, right? Every month you count month, you don't measure months, you count, right? So that's your discrete data. So you can see here, this is a monthly sales number, that how much sales happen every month. And you can see for some reason, February month has really low sales as compared to other months. So can you say it is an outlier? Yes, no,
Yes.
right? We can say it's an outlier, right? So that is how you identify. Okay, for continuous column, you can have histogram or box plot, whatever you feel more comfortable with. But for categorical column or for discrete data set, you can plot bar chart. Clear? So now once you have identified outliers, what do you do? So typically you can do both things. If there are very few, you can actually remove them. Like you can drop the entire row or you can drop the entire column. If it's like, if you think that is not adding any value. But if you want, you can treat them also. So treating as in, what do you think ideally, let's say if you found there are two values, which is, A is Y is more than 100. Even if I ask you with which value you should think that, you should be replacing it with.
Most repeated one.
Most rated one or basically average value or mode, right? In case of continuous data, it can be average value. In case of your categorical data, it can be mode, which is most frequent value. Okay, so that is what you can do. Cool. Now let's learn something, few more things about the modeling approach, right? So for the classification kind of a problems, we already saw there are two mainly kind of a problem in supervised learning: regression and classification, right? So regression is for continuous data, classification is for categorical data, when you have to, you have classes in which in between you have to choose. Now further in classification model, you have two major differences. One is binary classification, other one is multi-class classification. So as the name suggests, binary classification means when you have only two classes to predict with, right? For an instance, if I ask you if I email is a spam or not spam, so there are only two output, right? Two possible output, whether it can be a spam, or it cannot be, isn't it? Can you give me some more example of binary classification? Anything, wherever you think there will be two outcomes.
Classing
Sorry,
Gender.
what?
Gender.
Gender, right? So let's say if I ask you to predict something, right? So you will give two options, okay, that between male and female I want to predict, right? So it can be anywhere, wherever you think your target column, whichever you want to predict, it can only be two outcomes, that will be binary classification. But if you think it is more than two, that can be multi-class. Okay, so for an instance, I give you image and then I ask you that you have to predict whether it is a bird or a dog or a fish or something else, right? So I give you more than two options. That is what is called as a multi-class classification. Okay, so there are many modeling approaches, right? So logistic regression, decision tree, random forest. So I'm not gonna go in all the approaches in detail today. We are just going to stick with logistic regression. That's the simplest one and the most powerful one, I would say, especially if you have binary classification kind of a problem. Then logistic regression works like better than anybody else, any other algorithm. Okay, so we'll learn first that how does it really work, and then we'll see that how it is useful for our use case. As we said, right, today we'll focus more on the use case, on the credit card default prediction model. Okay, so as I told you that typically when you build a model, it is nothing but you have to collect all your input features, right? So as you can see here, we have collected all the features x1, x2, x3. You have to build a model which is nothing but a mathematical equation out of these inputs, and then you have to predict the outcome. So if there are two outcomes, that's a logistic regression model. It can be happy or sad. Okay, so let's see how does it really work. Okay, so but first understand that why we can't solve the same problem with linear regression. Okay, so linear regression also is nothing but, how many of you, what is linear regression, just to get an idea? Can anybody tell me what is a linear regression model or a problem? I want a quick answer. Even if you don't know, that's fine. You can say no, I'll proceed. But not given an answer, it's not gonna help. So shall I assume nobody know what is a linear regression model? Am I audible?
Yes, ma'am.
Okay, cool, no problem. So let's assume that linear regression model is nothing but simply, as I said, right, it's a simple mathematical equation which you are building. Okay, so let's take a very simple problem. Let's say that if I give you a height, have you seen that, have you gone for your medical checkup? They measure your height and then they measure your weight and then they tell you whether you are obese or not obese, or you should reduce weight or not reduce. Have you seen that scenario?
Yes.
Why do you think they tell you, on what basis they tell you that they look at their height and they look at their weight? Why do you say some to few people that you should reduce weight, few people they say that you are fine or you are underweight? How do they determine?
They calculate by using the BMI formula,
Body
body
mass.
mass index.
Okay, so but what is your input parameter?
Height
Your
and weight.
Height
in,
and weight.
it's just one, it is just height. Weight they don't input. So based on your height, they calculate what should be your ideal weight, right? And once they get your ideal weight, they come and look at your actual weight, and then based on, they say that if your ideal weight is less than your actual weight, they say that okay, you should reduce weight, you are overweight, or vice versa. That is how it works, right? So essentially this BMI calculation, however they are calculating your ideal weight, right? It is nothing but it's simply a mathematical equation, which you can say it's a linear regression model only, right? So your linear regression model, if I were to write an equation, it is as simple as y equal to, you can say a1 plus, or I should write it like this, weight, if I have to write, by weight equal to x height. This is what the equation is, and maybe that it is further multiplied with one another variable. Understood? So what they do is, based on that mathematical equation, based on the historical data point, let's say they all, because see, they have done that case study. You have to think like that, right? How they come up with that BMI index, that what should be the ideal weight? Because they have done 1,000 years of study, with all different kind of people. They know that what should be the ideal weight with respect to the weight, with respect to the height. So you can think like they have already come up with the equation. So A1 and B1 is already known to them. So if I ask you, if you have to insert height over here, let's say 5.2 inch in feet, whatever you calculate, can you get the ideal weight from this equation? Right? Yes or no?
Yes.
Okay. So that is why that is how they are getting to the ideal weight of this. And this is what nothing but your linear regression model. And this line, what you see here, it is exactly same. A1 your intercept, this distance is A1, and then this slope of this line is this B1. So if you have to draw this line, this equation, it is nothing but this line only. So what it tells you, whatever height, you will get the weight out from this equation. Let's say your height is somewhere here, you will get the corresponding weight. So this will be the weight. Is this concept clear to you, all of you people?
Yes, ma'am.
Yes, ma'am.
Right? That is how a linear, and this there is no data set. Trust me, this is all data science. It's all mathematical equation. It's no magic. Right? So this is how simple it is. A linear regression model. Now the problem, what is the problem here? So if I have to just predict that what will be the weight, I am fine, because it's a continuous problem, isn't it? It's a regression problem. I have no issue. I can use this equation and keep on predicting the weight for whatever height. But that is not my objective. My objective is I have to predict whether a person is overweight or not overweight. That is what I have to predict. So for that, what has to be done? I should know that threshold, that at this level, if my weight is more, it is overweight. So that is what you see here. That let's say if this is my threshold, let's say I keep it as 80. Okay. So if beyond 80, right, if I say that a person is obese, so that is what you will see here, that whatever values I am getting up beyond 80, ideally it should not matter. It should be restricted to between these two data points. Okay, so that is why we need a different equation. We can't use the same equation for logistic model, because simply for logistic regression I need only two outcomes, right? Yes or no? Because if I keep on using this, it will give me a absolute value, which I don't want. I want only two possible outcomes. That is why I need some modification to this equation, so that my output can be only 0 or 1. Okay, and that is what we call as a logistic function. So what we do is, if you see here, it is nothing but this logistic equation is nothing but it is 1 divided by 1 plus e to the power minus of this equation only. So it is this equation only. Beta 1 x1 plus beta 2. That is what you see here. Beta naught plus beta 1 into x. So what will happen? The outcome of this formula will always be between 0 to 1. Okay, and when it happens, when it is between 0 to 1, you actually check, like you can say that you can set the threshold at 0.5. So it is nothing but a probability basically. So probability of a event happening more than, let's say, 0.5, you can say it will be 1. Otherwise, it will be 0. Okay, so you can set it like this. For an instance, let's say you are calculating probability of being a obese person. So what you will do, you will insert all your input. You will insert your height basically in this formula, right? And let's say if the p value you got around 0.7, you can say yes, most likely that person is obese. But let's say if you get the value 0.5, 0.2 or zero point 0.3, less than 0.5, you can say that that person is not obese. That is how we converted a simple linear regression problem into a logistic one by simply modifying this probability formula. Take 2 minutes and let me know if you understood it. Clear or no?
Yes, ma'am.
Okay, cool. So this is how you build a logistic regression model. But now the another important aspect is, once you have built the model, how do you really evaluate? How do we do the model evaluation? Because see, in an ideal world scenario, what we do is we never build only one single model. We build multiple models. So I told you other algorithms also, right? Because of the time constraint, we can't cover everything. But in ideal scenario, we'll be running logistic regression, we'll be running random forest, and we'll be comparing those models based on certain metric. And then we'll say that which one is performing better. Okay. Now we have to learn how do we measure this? How do we measure the performance? So this is what we call as a confusion metric. Have you seen this before? Confusion matrix? Okay. So basically what we do is, let's say you had 200 data points, right? So the here I'm trying to solve a problem which is whether a email is spam or not spam. Okay. So think like I have 200 emails. Okay. Now based on this 200 emails, based on, let's say I built a logistic model, and now for every 200, for every record, I am predicting whether a email is spam or not spam. So I'm just predicting 0 and 1 based on the previous formula. So am I 100% sure that all the 200 data points will be correct? I'll be predicting correctly? No, right? There will be few wrongs, right? There will be few correct. So we will first put this confusion matrix to give you that perspective that how many of them are wrong and how many of them are correct. Okay, so for an instance, we divide this such that on your this side columns you have actual positive value which is spam. So this email is really spam or not spam. Okay, here you are predicting whether it is spam or not spam. Correct. So think like that. Out of this 200 emails, there were 45 data points which were true positive. So true positive as in they were actually spam, and you also predicted them to be spam. Correct? So this is what we call as a true positive. Similarly, there will be few mails which were actually not spam, but still we predicted those mails as a spam. So we call them false positive because we said that they are spam, but in reality they were not. So they were false positive. And there were 10 such mails. Okay. Similarly, there will be some mails which were actually spam, but we missed predicting them. We did not predict them spam. So we missed them. So there were 5 emails which we missed. So we call them false negative. Similarly, there will be true negative. In a reality, they were not spam and neither we predicted. So again, they were correct. So if I take few minutes and then tell me, what do you think? Which values should be more? True positive should be more or less?
More.
Should be more, right? You are correct, predicting correctly. How about false positive? More or less?
Less.
It should be less. We don't want to predict false positive value. How about false negative?
Less.
It should be less. True negatives? More or less?
More.
More. Right? So basically the diagonal element, you want it to be more, and off diagonal element you want to be less. This is what nothing but confusion matrix. So based on this, they've come up with this. Basically, there are three matrices you will hear: precision, recall, and accuracy. So accuracy is quite common one, but trust me, for classification problem, you should always look for precision and recall along with accuracy. Accuracy is not should not be the only number you are looking at. So the difference is in accuracy, what you do, you add both true positive, true negative, right? And divide by all the values. So in this case, it will be 45 plus 140 divided by 200. So what you see here is 92.5. So by looking at this accuracy, you will think, "Arey, wow, my model is so correct. The accuracy is 92.5%, which is huge." But at the same time, you have to look for precision and recall as well. So when you calculate your precision, so what is precision is that how many if you are predicting false positively. So it penalizes your model. So if you look at the formula, it is true positive divided by true positive plus false positive. So it actually accounts for your false positive. If you have more false positive, your number will be less. Okay. So if you do that, you will see your accuracy or precision is only 81%, which is, you can see here, almost less than 11%. So that's why I say that do not look for accuracy alone. Always look for precision and recall both. Okay. So this is how precision is calculated. Similarly, recall gives you a perspective of how many true positives you are predicting correctly. Okay, so it is true positive divided by true positive plus false negative. So you can think like recall is true positive divided by how many actual positive was there, right? So this is actual positive now. True positive plus false negative. This entire 50 is actual positive. So this is what recall is. 45 divided by 50. And precision is that how many of you predicted to be positive and how many of them were really positive. So it is like this: 45 divided by 45 plus 10. Okay, so it gives you both perspective. If these three terms are clear to you, how you calculate precision, recall, and accuracy,
Yes, ma'am.
right? See, you really don't have to do any calculation. Trust me, there are all library exist, and I'll show you in a while. But the point is that just because it exists and you don't have to calculate, it doesn't mean that you should not know about it. So all these things I'm covering in detail, it is being asked in interview. So don't think like you don't need it because you don't have to calculate manually. Python automatically does for you. That's correct. But still you should know it. If you don't know it, how will you improve? Tell me. Okay. So you should definitely know about these things. Any questions so far?
No, ma'am.
Okay. Cool. So now let's look at what all data science can do in banking and finance domain, which is actually like theme of for this workshop. So basically, data science has numerous application in this domain where it can help institution make better decision. So some of the problem statement which we solve is credit risk modeling is the first important one. Okay, so what does it really mean? So credit risk refers to the risk of borrowers defaulting on their loans or credit obligation. Okay. So some of you might have credit card, isn't it? Have you ever used credit card?
Yes, ma'am.
Yes, ma'am.
So when do you pay your bill? How does it really work? How does a credit card work? Can you explain me? Let's say you don't have money in your bank account. Can you still do a shopping? Let's say your credit card limit is 1 lakh. Can you do still a shopping of 50,000?
Yes, we can do.
You can do, right? That's the whole point of credit card, that you are taking credit from the bank, but you are in terms of the promises that you will pay it, right? You will pay it back. And when do you pay back?
There will be a billing cycle. We will pay according to
Exactly, right? So let's say every first day of your month, your bill generated, and then you will be given some 15 days or 20 days, depending on your credit card, to pay that amount. Okay, so that is how a credit card work. that you, even if you don't have money in your account, you can still do a shopping, and then when your billing cycle is generated, you have to pay that bill. But what happens when you don't pay your bill? Any idea? Anyone who did not pay their bill? Not that
Bank
I'll take
will
any action. Yeah.
they will levy our charges on our account, and they will convert it into EMI, and they will levy
Okay.
charges.
That is true. They will levy some charges. Let's say 3 months. I mean, they it is actually used some 10%, 11% they'll charge per month, right? If you're not paying that for that duration. But what happens after that? Also, I don't pay. So, any idea?
It will
Because
affect our CIBIL score as well. Like,
so what? I don't care. If I'm a fraud, I don't care about my CIBIL score, right? I don't care about. See, took a card and I made a purchase of 2 lakhs and then I'm vanished. I'm gone. I'm not going to pay it back. So that is what default means. Then it becomes very, very difficult for banks to track that how do you make that person, basically pay it back. If you're thinking it's that easy that okay, bank people will go to their house and then they will uh, take their belongings and things like that, that's never happened. It's very, very rare. So that's why banks has to take that call before even issuing the card, that what are the chances that person will default. Okay, so they build this model based on the historical data. That's why they take a lot of huge information when they are issuing card to you, right? They ask for your month salaries, they ask for your forms, ITRs, and whatnot. It's not easy. Like, obviously, the more the limit is, more are these kind of strict rules are that these all information you should be providing. So what they do is that banks already built this model beforehand, and whenever a new person come or apply for a credit card, they run your data into that model, and they look for that probability. If your probability is lower, then only they issue the card to you. Let's say whatever, there could be threshold, it could be zero point 0.5, it could be zero point 0.4, it really up to them, right? So the higher the probability is that you will default means you will not pay back, they will not issue you credit card, they'll reject your application. So that is what we call as a credit risk modeling. Understood? And this is the problem exactly which we will solve. Okay, so
yes,
likewise there are other applications also. Yes, is there any question?
No, ma'am.
Okay, so there are other applications also like fraud detection, algorithm trading, churn prediction, like many more application. But for now, today we'll focus on credit risk modeling, like credit card default prediction. That is our problem statement, which we will solve now. Okay, so basically, as I told you already, the problem statement is that we need to predict whether a customer will default or not on his credit card. And it's not like only one time they will do. They do it every year or every quarterly or every, annually, like, or however their cycle is. It really depends bank to bank. But I know for sure they do it for every year. Every year they check your scores, civil score, your behavior, and then they say that if your chances of being default is keep on increasing, then they might cancel your card as well. Okay. So credit card default occurs when a credit card holder fails to make a minimum required payment on their credit card account within the specified time frame. That is what we call as a default, right? So now the data which I will be sharing with you, basically it has the target variables. The target variable is basically it has default payment, yes or no, right? So there are actually I think 30,000 data points I'll share with you, in which all 30,000 data points you have it whether a person will default or not default. Okay, 1 means it will default, 0 means no default. And you have certain input features. So on that basis, you can build a model, right? So some of the input features is amount of the given credit. So basically, what is the limit of your credit card, right? So it involves both individual customer and his or her family. So sometimes you will see that you get add-on card also, right? Like you are the primary earning person, you will get one card, and they'll say that we'll give you add-on card also for your family member, maybe for your spouse or your parents. So even though it's a separate card, but all the billing will happen only in one card. Okay, so the point is here is the combined limit of all credit cards. What is that? Is it 1 lakh, 2 lakh, 3 lakhs, whatever it is? So that is also again input, a very important input parameter, right? Then you have another parameter as gender, whether a person is male or female. So one is for male, two is for female. Then you have education. Education, one for graduate, two for university, three for high school, four for others. Do you think these, let's say, gender or education, does it matter? Let's talk about education first. Do you think it does it matter? Just think intuitively.
Yes, ma'am.
How it matters. Let's say you are a bank and you have to give only one credit card out of two people. I'll say one person is IIT graduate. He's working, somewhere, or let's say you know that he is IIT graduate, and the other person is just maybe 10th pass. What are the chances that you think you will give your card to which person?
IIT graduate.
Right. So these things matter, right? So right, so that is why we are capturing all this information. What are their education, whether they are married or not, right? Again, you think that married people should be more responsible as compared to bachelors or singles, right? So one is for married, two is for singles, three is for others. Similarly, you have age criteria, right? And then apart from that, you have other columns. So there are six column actually, 0 to 6, actually seven columns. It is a history of past payment. So as I said, right, they do this check every year. So they are checking last 7 months of payment, whether you have paid it on time or not. So we are tracking the past monthly payment records from April to September, right, as follows. So pay zero will be the repayment status in September. So what was the status in September, whether you paid or not? Then pay one means in August did you pay or not? Pay six means in April how much you paid. So it is just that, I'll show you the data also in a while, but basically it has a record of your historical payment, how much you have paid to the credit card in last 7 months. Okay. Similarly, it is the bill amount, that how much was the bill. So see, need not to be both amounts are same, right? It may happen that some people do not pay the full amount, as some of you mentioned, right? Let's say my bill amount was 50,000, and there is something called as minimum amount you have to pay. So minimum amount would typically is hardly 10% or 15% of it. But the problem is that they charge you very heavy interest on the remaining amount. That's the catch there, right? So you can have, like, the point is that these two amounts can be different, right, depending on, if you are just paying the minimum amount, so that will be your pay amount, but your bill amount will still be higher. Okay, so last 6 7 months, how much expenditure you made on your card. And then this one is amount of previous payment is paid. So there is like uh, I'll just show you with the example that how, sorry, how much was the payment made in the previous month. Okay, so I'll just show you with example that how these three amount differs. So these are the input features which we'll be using to predict a credit card, a person will default or not default. Is this clear to you?
Yes, ma'am.
Is data set clear?
Yes, ma'am.
Okay. Yeah, any questions? No? Okay, so let's quickly move on to the hands-on. So as we discussed, the approach would be that first we'll be understanding the data, cleaning the data. We'll look at some data exploration, graphical representation, and then we'll think about the modeling. So the idea would be that I'll be walking you through step by step. We have actually now actually 1 hour, right? So we'll see that I also I will be giving you time in between to try out few things, but everything will not be possible. So first I'll try to capture everything, and then I'll give you enough time to practice and ask questions if you have. Is that clear? So I want you to open your notebook. All of you open your notebook, and I'll be sharing this data with you guys. So can I share here?
Okay, ma'am.
Yeah, just a second. In the chat, I will upload the data. Let me see if I can do that. Yeah, let me just upload the data, please. And I'll be uploading these notebook as well. Yeah. So I let me know if you can download, right? You guys can download the data. Can any of you confirm?
Yes, we can.
Yes, ma'am.
Oh,
Yes, ma'am.
sure. Okay. So let me just show you the data quickly. You guys can still see my screen, right? Yes, no?
Yes, ma'am.
Okay. Cool. So as you can see here, I have given you around 30,000 records, right? And then this is the your ID, unique ID of the column. You can ignore that. Then you have limit balance, that how much is the credit limit has been given to that particular card. You have here gender, right? Male, one is male and two is female. Then you have education, your four values. Then you have your marriage status, one, two, three. Your I think married, single, and others. Then you have age in years. Then you have these four columns basically, right? These 1 to 7 columns, right? So I think let me just 1 second. I think I okay, yeah, here it is mentioned properly. Yeah, so in the notebook I have mentioned properly. So pay 0 to pay 6 is historical payment. So yeah, just 1 second. Yeah, it says here, right? So -1 means it is paid duly, which means that there is no delay. So wherever you see -1 means there is no delay. It has been paid on time. Okay. So 1 means payment delay for a month. So I think 0. Okay, sorry. 0 means pay daily, pay duly. It is paid on time. -1 means, in fact, it is paid in advance. Okay, so -1 means it is paid in advance. 0 means paid on time. And then whatever you see apart from this, right? 1, 2, 3, 4, it has been delayed by that many months. So 1 means it was delayed by 1 month. Then 2 means it was delayed by 2 months. Likewise, if you see 9 means it was delayed by 9 or more. So that is how you can interpret these columns, that whether it was paid on time or before time or after time, and that too after how many months. So is this column clear to you guys?
Yes,
Yes,
ma'am.
no, right?
Yes, ma'am.
Okay, cool. And then you have this column bill amount, that how much was the bill was generated. This is a bill amount, that how much they actually spend. Okay, so few of them you can see 0 also, because it may happen, right? They did not made any expenses on that card for that particular month. So that's absolutely fine, right? So this is the bill amount. And 2, 3, 4, 5, 6, 2, 3, 4, 6, right? And then you have this payment amount from 1 to 6, which is again amount paid. So this is bill amount and this is amount paid. Okay, so likewise you have three set of columns, right? From for last 6 months, I would say 1 to 6, right? So basically this is for whether they paid on time or not, right? This is how much bill was generated, and this is how much they really paid. Okay, so these are the three set of columns. Then you have this last one, which is actually your target column, whether it is a person default or not default. Okay, so here you can see this person is default. Maybe the reason you are seeing here pay 5 and 6, it is actually 9. That person has not paid for more than 9 months, right? The bill this many time. Okay, cool. So data is clear to you? right? So don't worry about it. I have already shared
Yes, ma'am.
this notebook. So these details is mentioned in this as well. So you can go through it. Okay, cool. So now the first step is that typically we import all the library which we need, right? So we have already seen these libraries before, right? So as I said, we'll be importing pandas library, which is very important for loading the data from CSV or Excel file. We will have to perform most of the numerical options, so that's why we'll be loading NumPy library. And then these two library, Seaborn and Matplot, is for visualization. Okay, so here you can separately import math library, but again, here you have imported directly NumPy library, so it should work directly as well. Okay, we'll see where all we are using which library. So you will get an idea. But the first step is that you have to import all the library first. So of course, you should have installed this before. As I said, right, it's only one time activity. So if you have done it yesterday, then now you don't have to install it again. It will be already there in your system every time you open it. Until unless you are deleting everything, like you have deleted the entire or installed the Anaconda Navigator completely and then reinstalling. Then you may have to reinstall again, but otherwise you don't have to. Okay, now what is the first step? What is the first step? Load the data,
Important.
right? We have to load the data, right? Understand the data. So how do we load it? Simply this pandas library you have to call, and then there is a function. There are actually plenty of functions. So what I'll do is I'll show you one by one as well, so that you can get an idea. So pd.read if you do, and just press tab. Okay, so you can see here, just read and then press tab. You will see all these functions available to you available for reading. So I have shared you the Excel file. So which one we need? Read underscore Excel, right? And then read underscore Excel. After that, how what we have to give? So if you don't know anything about this function, there is one help shortcut I told you to see about the function detail. Anybody remember? I told shift tab.
DAR.
Shift tab, I told. So please make a note if you keep on forgetting. So if you press shift tab together, you will see how that function work. So one thing is you can simply Google. You can simply say that how pd.read Excel work. It will show you how it does it work, right? But if you don't want to Google, within Python, if you just press shift tab, it will show you the suggestion. So here you can see clearly it is a function you are calling, and you have to give just IO, which is nothing but input output path. So you can go and even check the examples. IO is nothing but it's a string, and you have to give the path. It is actually the valid URL or a path. And that's it. Others are default ones. So we saw yesterday, right? These are all the arguments it will take, but already there is a default value given now. So the point I'm trying to make is if I just directly run this, it will throw me an error. Right? What is the error? Can you read this error? Missing only one required position argument. So it's not saying too many argument missing. It's saying just one missing, because this IO is mandatory. Right? Which file you want to read, right? At least that you have to give. So that we saw that it has to be in string format. So all you have to do is just give that file name. So if you just press quotes, and here also if you press tab now, it will give you suggestion. So it will, because see, it is already in your working folder. So this working folder, if you have your data within this, it will show you automatically. So you can see here, I have actually the file name is uh, default. If you press tab, it will show you. So I have this file data, default underscore data dot xls. So I'll just select it and I'll close the string. And because I have to save it back, right? So I will save to a variable, maybe let's say df. Okay, and I'll just run this. So it will take a while. You can see this star symbol, which means that it's still processing. So it's not completed yet. As soon as it will be completed, number will pop up here. So you can add more cells from here. And how do you run this cell, by the way? How are you running this cell?
Play button.
So this run button is there, and another shortcut is if you press shift enter, right? If you press shift enter, it will be run. So for an instance, just look at this. I'm not moving my cursor, but still I'll be able to run. So my cursor in this cell, and I will just press Shift Enter key together, so it will run. So here you can see your actually data. So it is just like your Excel file, right? You have 30,000 rows, 25 columns, and all those columns have come here. So this is the first important step you learned. How do you load your data? Clear?
Yes, ma'am. Yes,
Should
ma'am.
I give you 2 minutes to try this out?
Yes, ma'am.
Yeah, just try this out. Let me know if it is done before that. Is it done? Shall we go ahead?
Ma'am, just scroll up. Like, what are the
So you
library?
don't have to import all the libraries as of now. Just go step by step, okay? So first import pandas as PD and ensure that this file which you have downloaded is in the same folder where you have created this notebook. Otherwise, you will have to give full path. See, because it has to be relative, right? So for an instance, if you want to check what is your current working directory, you just type pwd. Okay, if you just type pwd, it will tell you present working directory, and you can see it is in this folder for me. Likewise, it will show you some path in your system. Just ensure your both files, this notebook and that Excel file, is in the same folder, so that if you just give the name here, it will work. Otherwise, what you have to do, you just have to copy this entire path and give it here. So give it with the full path of the file.
Okay, ma'am.
Okay, cool. So I hope you all of you have downloaded, or all of you have read the data, right? So now you can just do a quick look and feel of the data, right? If you just do df.head, it will tell you the first 5 rows of the data. So you can see here df.head. If you just to look get the feel of the data, right? Similarly, if you do df.tail, right, these are the function. See, one mistake people make is they just do df.tail and that's it, they run it. So you will see sometimes it is run, sometimes it won't even run, it won't give you output. So one thing you have to remember, these are all the functions. Okay, so how do you call a function? You have to give the function name, and then you have
One,
to give this
one.
brackets. let me see, whenever you have a question, at least let me speak, complete my sentence, and then you can tell or ask any questions. Okay. So whenever you are calling a function, you have to put these round brackets so that you are telling explicitly that you are calling a function. And this is how you, like, once you run it, you can see that these are the last 5 records of the your data. So that is how you can see, like, beginning of the data and the end of the data. Now you can ask if you have any question. Is there any question?
No, ma'am.
Okay. Now what are the next step? What did I say while doing the EDA? You have read the data, you have seen the data. Now what you should do next? What was the first step in EDA process?
Loading the data set.
You have already loaded, na? So you have done the data set. I've done that step. I'm asking after that. It was not loading the data? Huh.
Data cleaning.
Cleaning the data. Now in cleaning, what is the first thing I told you? Look at the data types. Right? I told you, look at the data types, whether it is correct or not correct, right? So these are all the data. Again, you can go read in detail. So you can do the df dot shape. It will tell you what is the shape, right? It's nothing but how many rows and how many columns are there. So now this df dot info is very important. You can run this command df dot info. So it will tell you two main important information about the data. One thing is column wise, it will tell you what is a data type. You see data type column over here? It will tell you what is a data type so that you can confirm whether it is correct or not correct. So ID is the first one. It is telling what is the data type. It's an integer, string, object, what it is?
Integer.
Integer.
Integer, right? So it's an integer. So do you think it is correct? Yes,
Yes,
no.
ma'am.
Yes, ma'am.
Right? It seems correct. ID is integer. Yes, it is integer. How about this balance?
Integer.
Integer. How about this gender, sex column?
Integer.
Integer. Education?
Integer.
All the data looks integer to you? Correct?
Yes, ma'am.
No issue? So you can check here quickly. All of them it's integer. So this seems correct. There is no issue, at least from the data type perspective. See, our job is to check. I'm not saying that in every data set there will be a mistake or you have to fix it. But our job is to first ensure if it is not, let's say if it is, it would have been not, the integer, you would be converting this into integer. Now, how can you do it? Right? So there are different ways. So see, I'll tell you the very best thing, the hack. I cannot, of course, tell you in just 1 hour how do you solve all your problems. Okay, because I cannot capture all the scenario. But the best part is I'll show you how I used to do and how I still continue to do whenever I'm stuck, whenever I don't know what to do. Let's say for an instance, this balance, it's not an integer. Let's say it's in string column. So I will simply go to Google and I'll search how to convert string column to integer in Python. Is this something which you could have not written by yourself? You also would do the same thing, right?
Yes, ma'am.
Isn't it? So just drill down to your problem. What is that you are looking at, and simply Google. Okay, and there will be Geeks for Geeks or Stack Overflow. Have you seen this website before? Stack Overflow.
Yes, ma'am.
Yes, ma'am.
Have you used it? Like how do you use it?
For getting solutions for our errors.
Right? So this Stack Overflow is the best thing. Whoever has developed this. So basically, it's a forum where all the people in this whole world, especially in the in the coding language, be it Python or some other programming language, it exists for all the programming languages, but for programming language explicitly, if you have any problem, you can search over here. So somebody in future, in past, already might have faced the same issue. For an instance, you see, convert pandas data frame column from string to int based on conditional. This is what exactly you wanted to do, isn't it? Somebody has already asked this question 8 years back. You can look for answers over here. If you go here, it may happen that in first shot you will find, or if the second option might work. So you will have to test and try, but you will pretty sure you will get answers. So you will see here two answers as given, because it's slightly different than your thing. It says on conditional, but for you there is no condition, you just want to convert it. Okay, so maybe you can search some other different ways, right, if this is not working. So I would say first you try to work out with this. I think this should work. All you have to do is just df that column and as type int. If you do, it will simply store it back. Okay, so just to show you how it would have worked, I'll just show you maybe by creating a different column. So I'm just creating a dummy column. Okay, I'm just saying dumb, creating this column. And then what did it say? It says that you can pick that column. If you press tab, it will show you the suggestion. And if you just do as type and then just give the data type, let's say instead of int, you want to do it as a string. I'm just doing opposite. Okay. And that's it. You see, it has worked. Now, if I do df.info, you see it has created this another column dumb, and you can see the data type. Is it integer?
Object.
No, right? It's object. So basically, string it consider as object. So wherever you see string like object, it's actually string. So if you do df just head, if you check, you will see at the last it has created a column. So it, see, by look wise it still look like an integer, but actually it is a string. Python is treating it as a string. So that is why I said you have to be really careful. So when you do this df.info, you will realize, oh, it is an object column, but it looks like an integer, so it should be integer. So you should be converting it, back. Okay, so you can convert it like this only, right? So you can save it back. So here I created in a new column. You could have written like this only, like this. If you do it like this, it will be converted back. You see, it has converted back. Okay, so this is the our first step. So I'm dropping it because I don't need it. Okay, I just generated this dummy variable. I can drop it. So again, dropping is very simple. I can just do df dot. There is something called drop. So if I just press tab, it will come to you drop. You see, and if you press shift tab, it will show you how do you drop. So it tells you that you can drop it and then you have to give x's. Basically, x is 0 is for rows and 1 is for columns. So I need to give that which column I want to drop. So I will tell that, okay, I want to drop dumb. And I have to tell that, is it a column or a row? Is it a column or a row name?
Columns.
Column. So for column, always remember you have to give x is equal to 1. Okay. So if you do this, and of course, I'm saving it back into the DF. You will see it has been dropped now. So now if I again do df.info, you will see this, there is no such column. Okay, so likewise, if there is any extra column which you want to remove, that also you can remove. That is again part of cleaning. So just tell me one thing, in this thing, do you think ID column is needed? For model building, I'm asking.
No, ma'am.
It is like just like having a person name. Do you think even a person name should be included as a part of model building?
No.
Your name doesn't matter, right? Like if you in fact if you are using it, you are being racist, or you are being like it is not allowed or it is not permissible. You should never use these kind of ethical information to discriminate, right? You can't say that if a person's name, let's say some other, on some religious name, on some other thing, that you cannot say that based on this just name, you cannot basically discriminate that person will default or not default. That is what I'm trying to say. So whenever you see certain attributes, you should be dropping that. You should not use it for model building. So just now I show you how do you drop it. Okay, so you can drop it like this. Okay, so we did the second check also, looking at the data type and think that it is correct. Now, what is the next? What is the other thing I asked you to do? Look for missing data. Okay, so basically the best part to look at is here you can see there are how many entries? 30,000 entries, right? And here do you how many entries it says that it has non-null data? 30,000, right? So basically it has no missing data because total data was 30,000 and non-null data is also 30,000 for this column. So wherever you will see missing data point, it will be less over here. So let's say if you see somewhere 10,000 non-null data means there are 20,000 missing entries in that column. Okay, but here you see everything is 30,000 means that there is no missing data. So these are the two things you can check with this df.info column. One is the data type, column wise data type, and then column wise missing value. Is it clear? Can you run in your system this command df.info? Is it working? Can all of you say yes so that we'll proceed?
Yes, ma'am.
Okay, cool. There is other important feature is df.describe as well. So what this df.describe does, it basically gives you a stats. Okay, dot t means is nothing but it's transposing. So if you don't use dot t, it will just put it in this fashion, which will be too long. That's why we have done it dot t so that it's transposed. Okay, just to view. But basically, what it will have is because these are all numerical columns, right? Continuous numerical columns. So it can calculate. You can see here, right? Limit balance. How what was the value? So 30,000 values are there. What is the average value? So it is giving you the average value. It's giving the standard deviation. It's giving you the minimum value. It's giving you the maximum value. It's giving you all the percentiles. If you remember, we did draw that box plot, right? We did that, right? So it is nothing but that only. Just to give you a quick perspective if there are any outliers or if there are any missing things or something you should be suspicious about. So that will give you a quick glimpse of it, that how's your data. So what we'll see, okay, minimum value is 10,000, which is fine. Think like if their minimum value would have been 1 or 2 or 10 rupees, then it would be suspicious, right? You would praise it. Similarly, max value is somewhere it says 10 lakhs. So okay, that's huge. Maybe there are some person whose card is that good that it gives you 10 lakhs of cap. Okay, then you have gender, which is obvious, right? You have only one and two, which makes sense. Now imagine here if it would have been written three or four, then it would be a concern, right? Because you clearly said it can only have two values, one and two, right? So it's validity. These kind of validity checks you have to do by looking at this. Are you guys able to follow, or am I going too fast? You can just tell me because
We are following, ma'am.
you're following, right? Okay. Right. Same thing with marriage. See, all these things are very detailed. I cannot go in each and every column, but I would want you to do the same thing after this class. But I'm just giving you some tips. How do you proceed? Okay. Similarly, you will do this for education and marriage. Okay. Here you can see one thing, right? In bill amount, there are negatives. So negative means it's all paid in advance. Okay, so you can think of for there are still so many people who always put in advance. There are a lot of people, even I do that because I think that I will miss the deadline. So I always put some amount in my credit card in default so that I'm not missing the payment. So maybe that's why people are doing it, right? Negative it doesn't mean that it's invalid value. It's valid, it's just that they are getting prepaid. Okay, cool. Now there is another important one is checking for duplicates. That's again another important step of cleaning, data cleaning. That there should not be any duplicate entries, right? So for that, what you can do is again, see that's why I'm saying that pandas or this Python is so amazing that you just have to remember the step. You don't have to worry about coding at all. So as I showed you, right, how easy was it to look for all the all the stats. You don't have to write a single code. You just did df.describe, just one line one word of code you wrote, and it gave you everything, right? So that's why it's so amazing, because of this pandas library. Somebody has already written this function for you. The only expectation from you is you should know what to call when and how do you analyze it. And that is what it differentiate. See, lot of time people ask me that whether being this given AI and all those things, will it replace humans, or will it uh, will it create a problem issue in the job, right? It will replace jobs or not? The answer is yes and no, both. See, if these kind of technical things or technical analysis need to be done, that only a human can do. So that only depends on how good you are doing at. Because see, if it is a matter of just running this command, for that I can write this code. I have already written this code and it will work. But I need good human to analyze this and understand it better. That an AI cannot do. So that is where you have to differentiate yourself with a machine, that how you can do that better. Okay. So that is what, you can look for the duplicates. So I can just say df dot duplicates. If you do, just press tab, it will automatically suggest you. So duplicated, if you do, it will just tell you whether there are any duplicates or not. So just telling you true or false. So if you just encapsulate this with df, it will show you the entry wherever is, if there is any duplicates. But right now it says 0 rows, which means that there is no duplicate, so you don't have to worry about. But if you, let's say you had any duplicates, again it shows you a way. There is something called df dot drop. You see here, drop duplicates. So if you just do df dot drop duplicates, it will, and you save it back, it will drop duplicates for you. Okay, so that's again all already written by somebody else, and you just have to call it. That's it. Okay, so what did we do? We check the data types, we check the missing data, we look for the duplicates, right? And if you just do df dot columns, it will simply tell you what all the column names. Another way to identify missing data is you can just do df dot is null and dot sum. So that is again easier way. So there we were checking all the non-null data. Here you are checking null data. So it is all zero, means you have zero data points, like which is null. If let's say it says A is column 3 or 10 value, you can say that okay, 10 values are missing or 15 values are missing. But here, since it is all zero, which means that no values are missing. Okay, clear so far with me?
Ma'am, if null values were present,
Hmm.
how we can handle it?
Okay, if null value is present, you tell me. Let's say if in age column I say 10 values are missing, what you should do?
Drop the rows?
That could be one reason, one way to do it. Yes, you can drop the rows, or other ways you can fill it with missing values, with the average value,
Okay, ma'am.
right? So, say again, see these are, I mean, the reason why because it's just half an hour, I cannot capture all the scenario. But yeah, your question is valid, and simply now you can say that how do I do it? I would do the same thing. Just Google how do I fill missing values. So basically, to your surprise, already there is something called, I'm just telling you, and this is an homework, you can explore this. There is something called df.fill any. So what it does is it automatically checks for missing values and it fills it with it. So how to use it? You can just Google how do you use fill any in in pandas. You'll get the code. Okay.
Okay, ma'am.
So the best way to understand these code is you copy them, but you run it line by line so that you understand. You might get some 2 or 3 line of code how to use it, but the best part would be that you try to run it line by line so that you understand. Okay, so that is how you can fill any missing values if you have. Okay, so this is just a representation way. Let's say here it was all zero, so it doesn't matter. But let's say there would have been some data and you want to visualize it. Yes, of course you can. So we already called matplot library we imported. So we are just first defining the size. So this 14 row cross 5 size space we defined. Then here we are actually doing a heat map. So this heat map is nothing but of this value. So let's say if there would have been some other values, it would have been a different color. But just because here everything is 0, so you can see, right, 0 is red color, this color, right? So that's why you see everything is this same color. But if it would have been some other value, you will see these kind of different shades in this chart. Okay, so I would say take Google, get some other data also. But first try this one. If you feel once you are comfortable with this data and with this notebook, then I would say do the same thing with some other data. Try to download it from website. You'll pretty sure you'll file or on find on Kaggle data or something somewhere else, and then try to do the same thing with that data. Okay, cool. Now we can do some more kind of data pre-processing steps. Let's say I want to rename it, right? Because there are some columns which does not make sense, right? Like I don't know what is pay 0, pay 6. It's confusing. You can say that I want to rename the columns. So that also you can do. So how you can do is simply you do df.rename, and then you can say columns is something which I want to rename. So you are saying column, and then you can give in a dictionary format. Okay, so what is the dictionary format? You are telling wherever it says default payment, I want to change it to is defaulter or not. So that wherever it is 1, I know that it's default. It's 0, which means that it's not default. So let's say I just want to rename this. Right? So I just said that this is my old name and this is my new name. And after that, I have to write in place equal to true, because otherwise it will just rename it temporarily. It will not replace in the existing DF data. So either I write df equal to df dot rename and do this whatever I want to do, or I can just type in place equal to true so that it will replace in original data frame. So you can have, in fact, what is a shortcut to see the function rename function? If I want to see, I told you one shortcut, no?
df.info.
No, I'm asking shortcut to see the help of this
Shift
function.
plus tab.
Shift press tab. So you see here in place equal to default value is false, but I wrote here true. Can somebody read it for me? What does it mean in place equal to true? Can somebody read it for me? I'm speaking continuously from last 1.5 hours.
Modifying the data frame.
Rather than creating a new one. So it will modify the existing one, right? So you don't have to replace. So here what you are doing, you're actually creating a new one, right? Again with the same name. So that is not needed. You can just write in place equal to true so that it will store back in the original data frame. So same thing here, pay 0, you are replacing it with July, right? Sorry, with September. Then pay 2 is August, pay 3 is July. Like that, you are just changing the name. Again, this is not something is compulsory, but it is again depend person to person, right? If you are not comfortable with original names, you can modify it according to your convenience. So that is what we did, and you can see it has now replaced. Okay, this is one thing. Now, this part is very important. See, replacing the column name is the optional thing. You may or you may not want, because that has nothing to do with the calculation. But one thing is there, like we saw this gender, education, marriage column, right? So just think and tell me, gender column, whether being a male and female, should it be a continuous column or it should be a discrete column?
Discrete.
Same thing with the education. It should be a continuous column, even though it says 1, 2, 3, 4. 1 means undergraduate, 2 means graduate, 3 means postgraduate, whatever are the labels. But should it be a continuous column or a discrete column?
Discrete.
It's a discrete column, right? Or rather, better to say it's a categorical column. Because can 2.5 exist in education column?
No.
No, right? There is nothing like 2.5. Right? We have defined certain category. So it's better, because when you want to build a model, so that's why I say data type is very, very important, not for just visualization, but also for model building. So if something is numerical, it has to be numerical. If something is categorical type, even though it's number, being a number doesn't guarantee that it's a numerical column only. As I said, right, here you have numbers, but it doesn't. But education, it's a categorical column. Marriage, again, it's a categorical column. 1 and 2 marriage, it doesn't matter. It doesn't Makes sense, right? We are not counting how many marriages somebody did, right? So one means married, two means single. It doesn't mean somebody has done two marriages. Okay, so that's why these are categorical column. So you can do one thing is that you can just replace these value to the actual labels so that it's explicitly categorical ones, right? It is being treated as a categorical column. So here you can see we are replacing within the gender column, one being male and two being female. Similarly, in education, we are putting this. Then in marriage column, we are putting. Is defaulter also, we are making it explicit. It is a yes or no. Yeah, any questions?
Ma'am, the data types will be changed.
Yes, that is what we want, right? That is why we
So,
want. We don't want it to be numerical. That's why I'm trying to explain you. These columns, even though the input data is number, but these are not numerical columns. These are categorical columns. And that is what we are trying to do. By
for the
giving them
last
actual, sorry, go ahead.
data type will be object or boolean.
Yeah, you can just check now, df.info if you do. It will be object now. So it's all object now. And that is what actually you wanted.
Yes, ma'am.
Okay. Okay, cool. So now since we have fixed the data type, now we'll do some visualization. Okay, so what is the first thing you will check? See here, our overall objective is you want to see that person who default or do not default, what is their relationship with all the numerical columns? I mean, all the input columns. Isn't it? That is our main goal, right? So that is what we are trying to do here. We are actually first checking that dot value counts. If you do, it will tell you how many counts are there or not. So you can see there are 30,000 rows. Out of 30,000 rows, 23,000 rows are no, which means that they do not default, and only 6,000 people default. 6,600 people default, which is obvious, right? See, defaulters are always less; they are not more. Okay, so frauds happen are very rare. It's not every day happen. You think like that. You make daily 100 transaction, daily level. You are not getting fraud, right? So that's the whole point. So defaulters will always be less only. So that is why you are seeing here. Out of 30,000, there are only 6,600 defaulters were there. And if you want to plot it, you can just do it like this. pld.figure size, and if you just do sns.count plot and give the column name, it will simply plot it for you. So you can see it. See, I'm not going into detail. You already have a code. You can experiment with it at home. Just the building blocks, main blocks I want to cover in the interest of time. Okay, so here you can see we are quickly checking the how do you plot the defaulter settings, right? Then let's try to analyze, right? Let's see that in the entire data set, how much is the male and female ratio. So you can see it's not that bad, right? Female 18k, 11k, 12k is male. So in fact females are more in the data set. Okay, now if I want to see how the female ratio, so just think like that, right? Think intuitively. Okay, now let's say first column you pick is your gender and you want to see that whether females are more defaulter or as compared to males. How do I know? Okay, so for that you can simply have the plot with seaborn library. So there's something called count plot, and when you just do this, right, that you want to plot your gender column, and u is what you can give a category that how you want to split your data, right? And then you can just give your data frame. This is your data frame. Okay, so for an instance, you can see here on the left hand side, you are seeing one chart where it is just telling you female and male ratio. So we know that, okay, female is more and male is less. Okay, but within this, what is their ratio of being fraud or non-fraud, or defaulter and non-defaulter? So what we did is we simply splitted this entire 18k to this U column, splitted it. So here you can see this is no default and this is default. Okay, so by looking at this, take 1 minute and tell me, if I ask you, are are female more defaulters as compared to males? Yes or no?
No.
Why no?
As the stick of female is long when compared to the male.
Hmm. So
And default.
basically, you will have to look for the proportion over here. So how, if I just quickly calculate the proportion, so you can see there are roughly 4,000 females are a defaulter out of 18K. How much it is? 4,000 divided by 18,000, right? 22%. And if I look at the same ratio for male, here you can see it's actually 3,500 male only, right? It's 3,500 males divided by out of how many males? 12,000. Isn't it?
Yes,
12,000
ma'am.
males, है ना? मेरे हमारे
ma'am.
पास. Yeah. 29%, almost 30%. So of course, males ka ratio is more than female. Even though female are there more in the system, but still being more, their percentage between being fraud and not fraud, or defaulter or non-defaulter, is less than compared to male. So that is what you can see from this chart. Or you could have plotted a proportion as I did over here, right? That also will tell you. So this is one important insight we generated, right? That if a person is male, most likely that has more chances of being a defaulter as compared to female. We can make that statement, right?
Yes, ma'am.
Okay, so that is how we see proceed. We take one feature at a time, we make these kind of analysis, and that is how we proceed. And why we are doing it, you tell me. Let's say if I would have found out that gender is not adding anything, that the ratio here, the ratio is both same, 20-20%, it's exactly same, then what should I have said, or what should I do with that information? My ultimate goal is what? Build a model to predict whether a person will be defaulter or not. So do you think I should include this gender column in my model building?
It is not required.
Not required, right? If the ratio is same, which means that gender is not adding any value, which means that it doesn't make sense to add that in our model building. See, ultimately that is what we are trying to do, right? We are trying to build a model, and the whole point of doing a EDA is, just because let's say here 25 columns are given to me, should you blindly use all 25 columns and build a model and do some analysis?
No.
So that is why I'm telling you, if you were a machine, or if you were replaced by AI will do the same thing. It will simply build a model with all 25 columns, and then it will keep on iterating. But we don't want to do that blind iteration. We want to put our human intelligence into it. Why do I have to do 1,000 iterations? I can do that 1,000 iteration, no? More than 1,000 iteration. Put one variable at a time, build thousands of model, and then choose best out of it. That is what AI will do. But this is where we differentiate ourselves with AI, by saying that you don't have to build 1,000 model. I'll be building only one or two or three models at max, based on my judgment. So here we are doing that, applying that judgment feature by feature. So the same thing I'll repeat for education. So I'm not gonna do it again, but you can do at your own. So same thing we did it for education. So whether education is adding any important or not, you can calculate the proportion for here, and you can see whether I should include or not include. Same thing you will do with your marriage column, whether it is important. Again, it looks like it yes, there is a option. So being single, I think chances it is less default, looks like, right? Because there are many people who doesn't default. Okay, whereas this one is same, almost same. So looks like married proportions, the proportion here, it will be more. So more chances that if a person is married, they are getting default. Maybe their expenses are more. That could be a reason, right? We never know. Similarly, age, you can do the same thing. So age is a now, it's not a discrete column. See, it's not a categorical column. It's a historical column. It's a continuous column. So if you do this value count, it does not make sense for age column. So ideally, you should not be doing it. So you should be just plotting the histogram, which is what you are doing here, right? So count plot actually doesn't make sense. You should do the histogram. And here you can see, with respect to this default, so you can see that yes, So ultimately, the overall conclusion for these analyses are that yes, there are more females credit card holders. So number of defaults have higher proportion of females, right? Then number of defaulters have higher proportion of educated people. Number of defaulters has higher proportion of singles. So these kind of analysis conclusion at least you can make. So it is always important that whenever you are plotting something, don't just plot and do not make any inference. Always generate an insight and make a note of it. So how to do it? Sorry, I think I forgot to mention. So see, if you just add anything, by default it's a code. Okay, you can see it's a code. But let's say you want to write text like this. So if you see, this is not a code, it says it's markdown. So if you want to write something which is not a Python code, but you just want to write a free text, you can convert this in Python. Sorry, you can convert this in markdown and you can just type whatever you want. This is a sample
Hi Neha,
text.
sorry to interrupt you.
Yeah.
Can you give me the co-host access to me? Like, and chat option is disabled.
Okay, I'm not sure why. I can give you the from where I can give you the co-host access.
Like you can see the participants. You
Okay,
can close
I
this
will.
window. Yes. Yeah, I join. Like chat option is disabled.
Oh, but
Now
it
it's
already shows co-host.
okay. Now it's coming. Okay.
Acha,
Thank you, Neha.
I didn't. Yeah. Okay, no problem. Yeah. Okay, so once we do the analysis, then there is another important things which is as correlation. So what this correlation does is that this is another way to see that how two variables are related to each other. Okay, so when you do this df.core, like you can just write numerical only, because ultimately only for numerical columns we calculate. It doesn't apply on categorical column. So it simply tells you that how two variables are related to each other. For an instance, you can see here age column with limit value, right? So it's very less, it's very poor, right? Similarly, this value is between 0 to 1, right? So anything which is more than zero point 0.5 zero point 0.7, we say it's highly strongly correlated. Anything which is lower than zero point 0.5 or 6 or 7, we say it's poorly correlated. So that's why you're seeing here, right? Of course, age with age it is one, right? You are mostly correlated, you know each and everything about yourself, isn't it? So that's why age with age is one. But whereas with other variables, it will tell you that how it is correlated. So again, this is an important way to find out. As I said, right, we are trying to understand that which columns are important for model building, and that is what we are trying to understand. So this also help us to identify that which two variables are strongly correlated. So I can do this like for all the columns. So in my case, see, the target column is a categorical column, so it's not that useful at this point in time. But think like if it is a regression column, it would have been very important. So I would have looked at that, okay, with respect to Y column, what all columns are really important, so that I will definitely use that for my model building. Okay, see, same thing I can do here. Here is something, this column is 0.8. Let me see, this is bill amount APR to bill amount September, which again makes sense, right? See, your spending of this month actually strongly correlated to your previous month's amount, isn't it? Because typically people purchase a credit card for certain tasks, right? To buy grocery and to buy a household stuff. And most of the time their household stuff on monthly basis gonna be remain same, more or less same. So it will be highly correlated. That is what you are seeing there, isn't it? So these kind of things you can see here. This is again reading a heat map. So I already showed you how to read a heat map. I'll just quickly jump to the modeling part, that how do you build a model and how do you analyze it, right? So simply, as I said, wherever you have, see, categorical column, right? So you have to do the encoding for that, because I just showed you the equation. It's a mathematical equation, so only numbers can be fitted there. You cannot use any strings in the model building. So you have to convert or you have to encode it. Okay, so that is what we are doing here. We are just encoded again back to female as 0, male as 1, and we already know for this one, right? So we already encoded this. Okay, so earlier we have to convert back into category, because otherwise I'll not be able to create those charts. So that's why having the correct data type is very important. Okay, so here again I'm converting them into a number. However, for other ones, right, education and marriage is something I cannot do with 0 and 1, because it's not just two labels, right? So there is another method called PDDF get dummies. So I'll just run this and show you how does it really work. So you see here how many columns are there? Still there are 25 columns, right? But when I do this get dummies and I just give the columns of categorical column which should be converted into numerical. So I'll just do this get dummies and you can see the shape. So it has been increased to 30. And why? I'll just show you the df.head. So basically what happens is, look at for this education column. So earlier there was only one education column, and within that column it was written that whether it is graduate, high school or others or university, right? Now instead of that, there are actually four columns created. 1, 2, 3, 4. How many labels are there? That many columns will be created. And all it has is just true and false. Okay, so here you can see this person had in the education column, they had the university. So that's why you see education university, it is true, but for others it is false. Okay, so likewise they put. Similarly for marriage, there were three columns. So three columns are three values and three columns are created. Marriage married, marriage others, and marriage single. So whatever is the value was true, right? So that's why you will see there will only be only one true for this particular column. Others will be false, right? Because for this entry it was married. So that's why it's true. For this value it was single. So that's why it is true and others are false. So does it make sense? Do you understand this process? Yes, no? Am I
Yes,
audible?
ma'am.
Yeah.
Yes, ma'am.
You understand it, right? See, and why we are doing it? Because it does not modeling does not understand words or objects. That is why we have to convert it like this. So it understand only numbers and true false. But because true false also will be ultimately converted into 0 and 1. 1 being true and false being 0. So it only understand numbers. That's why we are doing it. Okay. So once we have done it, right? Once we have done it like this, okay, so what we are doing after that, we have to build the model. Okay, so for modeling, what we are doing is uh, okay, so first I'll show you. First I'll ignore this, I'll cover this. Is it okay if we extend 10-15 minutes more, Trinath and others?
Yeah, fine. You can check with the students.
Yeah, are you guys okay if we just extend 10 more minutes?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay, perfect. Okay, so this is how we have handled the input variable. Now there is one more thing. Okay, so if you observe, there were actually the class was highly imbalanced. We saw out of 30,000, only 6,000 data points were there, which was defaulters. Remainings were not defaulter. Okay, so to handle these kind of imbalanced data, there is a technique called SMOT, which we have to add more and more data points. So basically, it is nothing but you can think like, if I build my model based on that data, where only 6,000 data points has the defaulter and remaining 24,000 has a non-default value. Do you think it will be a good model to predict for the default data set? It will predict with that good confidence, because you just has your, or which will empower which one, defaulter ones or non-defaulter ones, which population is more?
Can you repeat the question?
Okay, okay, let me rephrase it. So what I'm asking is, you understand that this modeling is part is not magic. It is all what you pass whatever data you pass in your model. Agree? So in historical data, you have seen that your majority of the data is non-default. So what do you think? Predicting the default value will be, will be more accurate, or non-defaulter will be more accurate if you build your model on the historical data? What is the majority?
Predicting
Defaulter will
non-defaulter,
be accurate.
predicting not
Non-defaulter will be more accurate, right? Because you have almost how much percentage? Almost, I would say 60% of that, not 60, 70%, 70, 80% of the data which is non-default. Only 20% of the data which is there, which is default. Okay. But what is our prime objective?
to
Think like that. You are a bank.
predict the defaults.
You would you would want to give. Is it okay that you don't issue a card to a person who was genuine? Is it okay? Or which is, I would say, more okay, that you have issued a card and that person could be a defaulter? It is okay that if even if you don't issue a card to a good person, that is still acceptable, because you are not making any losses. You are not just making any profit, but you are not making any losses. But in the other case, let's say you have issued a card to a person who will not return your money, you are making an actual loss, right? So that's why predicting the defaulter is more important for you, rather than over predicting a defaulter. Let me put it this way. Do you all agree with me?
Yes, ma'am.
Yes, ma'am.
Right? So how do you so we call this problem as an imbalance problem. Whenever, see, balance problem would have ideal scenario kya hota? You should have equal data points for both of them. If there is a 30,000 records, 15K should be from defaulter, 15K should be for non-defaulter. But that's not the case. You can't control that, right? So how do you overcome with this problem is, there is something called SMOTE technique, synthetical minority oversampling technique. I'm not going too much of detail, because already libraries exist for this, so which you can leverage directly. But I'm just giving you high level concept. So what it does is, it will generate synthetical data for you for that minority class, so that you have a balanced data. Okay, so you don't have to do anything, not a single calculation from your end. Only thing is that you have to just import library. So all there is a library called imb learn. Okay, imbalance learn. So you can just do this pip install imb learn, and once you do this, you can see here, from this library, from this oversampling function chapter, we are getting smote. So this is the function name which we are calling. And once you have called it, right, you have called it here, all you are doing is fit resample. So you are trying to fit and extract the sample from this data. So you have just, given this data frame of yours, df data frame, and then you are simply passing this, if you just see fit sample, what it does. I think I have to run this. But ultimately what it is doing is, it is just checking that in all the columns, right, wherever it is not defaulter, right, wherever it is actually, what do I say, it is giving you, actually it is 0 and it is giving you 1, so it actually resamples. So now here you can see your original unbalanced data set was this. Now this is your balanced data set, right? This is after resampling. So it added almost 16K record extra. And when it does it, and if you want to see the balance data, you can see now it is 23,000, 23,000 each. So this is a balance data. Earlier it was 24,000 non-defaulter, right? And only 6,000 defaulter. But that ratio has been changed to 23, 23 each. So for this to understand, for this code to understand, I would say that just do it line by line so that you understand it properly. In the interest of time, I'm not just running it line by line. Otherwise, I would have shown you how to. All you have to do is just remove this line, right? Just copy this line and run it in a different cell. You will see what you are getting. Similarly, here, you run this and see what you are getting. It's not that difficult to understand. But the whole point is that this chunk of code, it takes your input data and it gives you output as your sample data, which is balanced. Is this clear?
Ma'am, what is synthetic data?
What is synthetic data? Synthetic data means which you are generating, artificial data. That is what synthetic means. Okay, so once you have generated it, we'll come to how do we build a model, right? So for building a model, we typically divide our data set into training and test. And that is what we are doing over here, training and test. So again, you don't have to do anything mathematically at your own. Already functions are available, libraries are available. You just have to call the right function. So here you can see there is a library called sklearn library. So from that sklearn library, you are just importing this train test split function. And when you pass your x and y over here, and you just have to give that how you want to split. So let's say you just want to create your test as 20% and training size and 80. So what is the training and test data? See, you are building a model, right? You are training a model, but you also need some data to test it. So you already have a data set of 46K records. So now you will split that data into training and test so that you can train your model, build your model on training data, and then you can test it. You have to evaluate your model as well, right? So that is why on the remaining data you can test. So of course your test, typically we take the ratio of 70-30. Okay, or 80-20 is also acceptable. Here we have taken 80-20. So typically 70-30 or 80-20 we take. So we have taken here. You can see the shape of it. So out of 46, 37,000 records will be used for training it and 9,000 records will be used for testing. And again, training the model is very, very easy. From again this sklearn library, there is this model exists, logistic regression. All you have to do is just call this model. You just say fit intercept and you just fit it. In the while fitting, you just tell this is my x and this is my y. What was my y? I think I showed you here. Your y is this, is default column. This is your y, right? 1 and 0. So this is your y and the remaining column is x, right? So you can see here, all these columns are x and this is your y. So this is what you have given here, x and y. And what you are doing once your model is fit, you are simply predicting it on your text data, right? So once you have predicted on your text data, right, and you are again predicting on your trained data also, just to see the numbers. And those accuracy which I told you, right? Three terms I told you: accuracy, precision, and recall. Again, these thing functions you can call it from sklearn metrics. You don't have to write that formula at your own, the formula which you saw. I showed you, right? But you should know how it is calculated, but you don't have to do it manually. All you have to do is just, call these matrices: accuracy score, recall, precision, confusion matrix. You can ignore F1. This is nothing but combination of the two. But these are the three important ones. And that is what you are seeing here. So we are calculating these accuracy on training data also and test data also. So you can see, ideally it should be same. It should not be very much different. So that is what you are seeing here. Accuracy on your training data is this much. Accuracy or test data is 82.9, which is quite close, right? Similarly, precision on your test data is 80%. Recall on your test data is 85.6%. Not bad, right? Quite close. Accuracy you can calculate. So likewise, you can calculate different matrices over here. So that is how you have built a model. So whenever a new data come, you can actually use the same model. This is a good enough model, isn't it? You can say that overall your accuracy numbers are 80%. Lowest is 80, right? So that is how you use the data, clean the data, build a model and use it. You can actually build a confusion matrix to see like this. Yeah. Any question, confusion? I know it's a bit too much to be digested in just a short class, but it was just a demo, as I said, right? We just want to give you a flavor how things really work, and of course you have to learn details. See, in just 1 hour class you won't get it that what all this different matrices, but we just wanted to give you a flavor that how things really work, and then how you can also run at the same time. We want to give you a confidence that you, yes, you can also run it. So we have already shared this notebook. We have already shared the data. You please try to run at your own. And as I said, best practices, you always try to run it line by line at your own. Even though don't try to execute this single code at one time. I would say just copy this line, create a new cell, and type it here, and then just do it. I would say even type it. See, I have not run all the cells, that's why it's giving me error, but you should not get any error if you have run sequentially. Are there any questions, queries, any feedback, anything which you do not understand?
Ma'am, how to end this project? What's the conclusion?
See, the conclusion is, of course, these are the insights which we made, right? That was a conclusion. Okay. And the end goal was to build a model which can predict whether a person will be defaulter or not. And that is what we did, right? So ultimately, at the end, we built a model which was predicting with 80% of precision, right? 82.7% of accuracy. So now what will happen? This model is good enough to put it in a production. So business can take it up, so that what will happen whenever a new entry come, you already have now these insights with you. You already have a processing code. You can do perform that pre-processing, and you can predict whether that a person will be a defaulter or non-defaulter. Does it make sense?
Yes, ma'am.
Okay. I just wanted to show you one thing more. Let me just run it quickly. Yeah. So you see here, if I just show you this wipe red logi stick, it is nothing but, you can see here the length of this would be, it's an array, and you can see it's all 0 and 1. So it's nothing but you are predicting whether a person is a defaulter or non-defaulter, and you are doing it for all 9346 people in one shot. So this is what your test population was, right? So you separated your 9300 people separately to predict whether that person will be default or non-default, and that is what you are predicting here. And when you are calculating this accuracy score, right, this is what you are doing. So you are actually building this confusion matrix. So I showed you, right? So here your true labels, here your prediction, and then this is something called true positive, true negative. Okay. Understood? Yeah. Anything else? Any other questions you guys have? How did you like this workshop? Do you think it was good enough, or it should have been more detailed, or what is your feedback if you want to give?
More detailed.
But then for that it has to be longer, right?
Yes.
4 hours is, this is what you can do if you have to start with basics. Anything else? Okay, if nothing, then that's it from my side. Trina, do you have anything to add?
Yeah, Neha. Regarding material, tomorrow we will share the drive link in the WhatsApp group. And as of now, we shared the quiz form in the chat box. So you can fill the form and complete the quiz. And if you have any queries, you can ask in the chat box. Yeah, sorry guys, I hear a network issue. So regarding material, tomorrow we will share the drive link in the WhatsApp group, and we share the quiz form in the chat box. As well as tomorrow we will share the drive link of all the materials and quiz form and assignments. And the assignments part in the PPT you will be able to find in the last page assignments. Okay. Am I audible to everyone?
Yes, Rinath, you're
Yes,
audible
yes,
now.
yes.
Yeah. Okay. Assignments are in the PPT as I shared in the chat box. Okay. Again, I'm sharing that PPT in the chat box. You can take it from there. And tomorrow we will share in the WhatsApp group. Like those who didn't join the WhatsApp group, I'm sharing that WhatsApp group link here as well. I posted WhatsApp group. Tomorrow we will share all the drive links regarding recorded videos and materials and assignments. Everything we were sharing in this WhatsApp group. So if you're not joining the WhatsApp group, you can join there. And PPT one more time I'm sharing here. Okay.
Okay, sir.
Okay. And the certification we will share it by email in the next week. Those who fill the feedback for the 2 days, we will consider it as attendance. Okay. In the next week, you will be getting the certificate via email. If you're not get the certificate, just reach out on this below mail ID. I'm sharing that mail ID in the chat box. So you can drop a mail. So any of sort of queries, you can drop a mail to reach us at the rate of coursevita.com. Okay. Yeah. Yeah, that's it from my end, Neha.
Okay, Srinath.
So
I
we
will
can
also be. I'll be mailing you the notebooks and the notebooks. I think, and the data set, so that you can share. I have already
sure.
shared over here, but yeah, you can again forward everything. Thank you, guys.
Sure.
Have a good.
Again, you can share it via email. I will upload into the drive.
Sure. Okay. Thank you.
Thank you. Just a moment. I posted I posted it in the chat box. It's taking time to.
Yes, sir.
Sir, can we leave?
You can leave, like PPT we are sharing tomorrow drive link. It's a 10 MB, so it's taking time to post in the chat box. Tomorrow we will share the drive link. We will share that WhatsApp, the PPT and material, all the materials in the WhatsApp group. Okay. Yeah.
Okay, sir.
Thank you guys. Have a great day. Bye.
Thank you, sir.